Guys, are you able to hear me? So I hope you guys are able to see my screen. Right.
Yes, sir.
Yes, sir.
Okay. So we'll start with the wave optics chapter. So I hope most of you know the basics already. So the only thing that you didn't learn this year in your CBSE about from wave optics is one is polarization concept that got missed. Second is what will happen in Young's double slit experiment if there is any other medium which is placed in between the slits and the screen. Okay, these two are the only extra concepts. Before that, let me go through the theory part on a very basic level. I'm sure everybody knows the basics for CBSE, right? There is any doubt, please stop me and ask. So I hope everybody knows the Newton corpuscular theory. That is, before light was considered as a wave, it was assumed to be particles. So that's what corpuscular means. So that's what this theory speaks about. But Huygens was the scientist who proved the wave theory of light. So he was the one who contradicted Newton saying that light is not a particle, rather it is a wave, right? And there were, then he came up with the concept of wavefront. So wavefront is nothing but a continuous locus of all the particles of the medium which are vibrating in the same phase. So there are different kinds of wavefront that we know what is spherical wavefront, cylindrical, and plane. So what is spherical wavefront? So it is produced due to a point source. So when is a cylindrical wavefront produced? It is produced due to a linear source. When is a plane wavefront produced? When the source is at infinity. So there are some important points that are not there in your CBSE which you need to make a note of, write it down. So in the case of a spherical wavefront, it is observed that the intensity is directly proportional to amplitude square. So everywhere it is. So that's the principle that is followed with respect to light. So intensity is directly proportional to amplitude square. Similarly, for a cylindrical wavefront, when the source of light is linear, the wavefront is cylindrical. Okay. So here one more point is that amplitude is inversely proportional to the distance. A is inversely proportional to x. Please make a note of that point also. Whereas for a cylindrical wavefront, the amplitude is inversely proportional to root of x. Whereas the intensity is directly proportional to amplitude square, and it will be directly proportional to 1 by x. Then what about a plane wavefront? When the source of light is very far off, the wavefront is plane. That is, the amplitude is directly proportional to x power 0. So the intensity is also directly proportional to x power 0. Please make a note of these points. Okay. So Huygens principle, you guys know that every point on a given wavefront acts as a source for the secondary wavelet. On the secondary wavelet, if you keep every point and draw the locus, that will give you the secondary wavefront. Right. So based on that, you have the concept of proving the reflection and refraction of light using the wave theory of light. Right. So I hope there is no doubt till Huygens principle. Any doubt, guys? Shall we proceed?
Sir, actually, சார் இந்த மாதிரி இந்த ஹைகன்ஸ் பிரின்சிபல்லாம் வந்து அது நிஜமாவே அப்ளிகேஷன் மாதிரி ஏதாவது கேள்விலாம் இருக்கா இல்லாட்டி வெறும் இது மாத்திரம் மக அடிச்சு மாதிரி
Huygens principle வந்து it is only to prove the wave theory, prove the concept of reflection and refraction using wave theory. But actually அது இருக்கு அந்த பிரின்சிபல் வச்சு தான் we are able to proceed further. ஏன்னா Huygens principle ஒன்று இல்லைன்னா you will not be able to visualize Young's double slit experiment, or you will not be able to see diffraction, nothing you can see.
ஓகே
அது ஏன்னு சொல்றீங்க? I'll come back to the point you asked after I explain Young's double slit. See, this concept of superposition of waves is important for us. Why? Because everywhere you see there are different light sources. There is nothing like there is only one light source in this world. So from the different light sources, you have different waves that are emanating out. Then what will happen to these waves when they superpose on each other, when two similar waves propagate in a given medium simultaneously, then if you want to find the resultant at any point in terms of displacement, okay, which is equal to what? It is equal to the vector sum of the displacement produced by the individual waves. So y is equal to y1 plus y2. This is a mathematical expression. This we all know. So based on this only, we will come to the concept of interference of light. So when you observe the interference of light, you can go with the analytical method, that is using the mathematical application of trigonometry, or you can go with the theoretical method. What does the theoretical method state? That is, when you have a screen like this, right? When there are two sources which are separated by a distance small d, and these two sources are at a distance of capital D from the screen, then what will happen? There will only be a single source. So on the single source length, what will happen? There will be different wavefronts which are coming. At this point, what will happen? The wavefronts are broken into two separate parts. Your wavefront, your wavefront. So again, this will be a wavefront, this will be a wavefront, this will be a wavefront, this will be a wavefront. So this keeps on going. And are you able to see the point of intersection of something? If these wavefronts concept was not there, then what would have happened when the light travels only in the form of rays? Then you should have found the bright light all over the screen. But no. When the size of the slit is very small, that is, if it is very small compared to the wavelength of the light that is being used, you are able to find different patterns of consecutive bright and dark fringes. Correct? So how are you able to explain it theoretically? It is only because Huygens came up with the concept of wavefronts. So theoretically, it is an important concept, and yes, you are able to see it on the screen also. Because that kind of a phenomenon which is being formed on the screen is possible only for waves. It is not possible for particles. That is the concept based on which electron was proven to have dual nature. So that's where it is applicable. So this interference of light mainly speaks about what? When you have two light waves of similar frequency, they are called as similar frequency having a zero or a constant phase difference propagate in a medium simultaneously. All put together, similar frequency and zero phase difference, all put together is called as a coherent source. So when you have a coherent source which is propagating in a medium simultaneously in the same direction, then due to their superposition, what you can observe is maximum intensity is obtained at few points and minimum intensity is obtained at few other points. Okay, the phenomenon of redistribution of energy due to the principle of superposition of waves is what we call it as interference of light waves. So the interference taking place at points of maximum intensity is called as constructive and the other is called as destructive. Now let's jump into the direct condition. So what is the mathematical relation in terms of phase difference and path difference for a particular point to have a maxima or a minima? So for constructive interference, what should be the phase difference? The phase difference is supposed to be an even multiple of pi. And the path difference is supposed to be n times lambda. That is an integral multiple of wavelength. For destructive interference, what is going to happen? The phase difference is going to be 2n minus 1 into pi. And the path difference is going to be 2n minus 1 into lambda divided by 2. That is an odd multiple of lambda by 2. Right? If two waves are exactly of same frequency and amplitude A and B, then the amplitude of the resultant wave is going to be R is equal to root of A square plus B square plus 2AB cos phi, where phi represents the phase difference. So you will apply the value of 2n pi or 2n minus phi depending on constructive or destructive interference, and then you will proceed. If phi is the phase difference between the two waves, then R max is equal to A plus B, then R minimum is equal to A minus B. So the resultant will be maximum when the value of phi is 0, and the resultant will be minimum when the value of phi is minus 1. So if you take these values and substitute it here, you will get the answer. So these are all important formulae. They'll be used in the problems. So I is equal to A square plus B square plus 2AB cos phi. See, actually, R square is equal to A square plus B square plus 2AB cos phi, correct? But R square it is intensity. Intensity is equal to A square plus B square plus 2AB cos phi. If I write a square and b square in terms of I1 and I2, this would be root of I1 plus root of I2. Sorry. I1 plus I2 plus 2 times root of I1 into root of I2 cos square. So, where I1 and I2 are the intensities of both the waves. So remember this, okay? This is an important condition, and there will be definitely you will be having problems which are based on intensity. Next, coherent sources of light here. The source of light emitting light of same wavelength, same frequency, having zero or a constant phase difference is what we call it as coherent sources of light. Right. Next is Young's double slit experiment. So the arrangement of YDSC to produce interference is shown below. So what is the position of a bright fringe? So what is the position of a bright fringe, guys? So it is given as n lambda into capital D divided by small d, where n represents the nth bright fringe. Similarly, the position of a dark fringe is given as 2n minus 1 into lambda into d divided by 2d. Okay, then there is a concept called as fringe width. So fringe width is the distance between the centers of the two consecutive bright or dark fringes is what we call it as fringe width, and it is given by the formula. For example, 2 lambda into capital D by D minus lambda into capital D by D is going to be the fringe width. Lambda into capital D divided by D. There is the fringe width. So the angular fringe width is given as lambda divided by small d, where d is the distance of separation between the slits. Okay, lambda divided by d, or we can call it as beta divided by d. One minute. So lambda can be written as beta into small d divided by capital D. No. So lambda divided by d is beta divided by d. D and d will get cancelled. This capital D gets make a change. So lambda divided by small d or beta divided by capital D. Right. So what are all the important points related with fringe width? So fringe width is beta is equal to lambda into capital D by D. So beta depends on 3 parameters. What are they? Wavelength, the distance between the slit and the screen, and the distance between the slits. So beta is directly proportional to lambda. So two conclusions can be drawn. If IDSC apparatus is immersed in a liquid of refractive index mu, then the wavelength of the light and hence the fringe width decreases by mu times. Why? That's what the definition of refractive index states. Okay. So lambda dash will be equal to lambda divided by mu. Next, this is also an important point. This will be given in some corner in your CBSE textbook. If white light is used in the place of a monochromatic light, then colored fringes are obtained on the screen with red fringes of larger size than the violet, because the wavelength of red is greater than the wavelength of light. Okay, so there is an important point here. If you observe, the center is still going to be white because the path difference there is 0 for all the colors. Hence, all the wavelengths interfere constructively. At other places, light will interfere destructively for those with wavelength for whom the path difference is lambda by 2, 3 lambda by 2, etc. And they will interfere constructively for the wavelengths for which the path difference is lambda, 2 lambda, so on by etc. Okay, so I have already told you in CBSE what is the important condition for a destructive interference to take place. What is supposed to be the wavelength or the path difference between two successive waves for a dark fringe to be formed? It is lambda by 2. Okay. So otherwise, destructive and constructive are mentioned. Similarly, make another important note. Shape of fringes on the screen is hyperbolic, but the screen is placed at a very large distance from the slits, then the hyperbola nearly looks like straight line in shape. This is another important point. Actually, if you observe the shape of the fringe, they will actually be the shape of a hyperbola. But since the distance is very great, the curvature will appear like a straight line. Okay. Guys, I hope it is clear. So there are a few more formulae that you are going to see. Angular width of fringes. So how do you calculate the angular width? I want you guys to tell me. Suppose the source is here. This is the bright fringe. There is another bright fringe. I'm asking you to calculate the angular width here. I'm asking you to calculate the angular width here. அப்ப என்ன பண்ணுவீங்க? So this distance. Tell me.
Since the angle is small, we can approximate tan theta to theta, and then.
Okay, tan theta can be approximated to theta. Okay.
Then we can write it as y by capital D.
What is y?
Beta.
So for the way I have taken y1 divided by capital D. Correct? So y1 divided by capital D is going to be lambda d divided by capital D. Suppose I want to calculate the angular. Suppose I want to calculate the angular width of nth fringe. What am I supposed to do? Let us say this is nth fringe and this is n plus 1th fringe. So the nth fringe is making an angle theta n, the n plus 1th fringe is making an angle theta n plus 1. Then what is going to be the angle between these two? It will be theta n plus 1 minus theta n. So what is beta n value? Sorry, theta n value is n lambda divided by d. Theta n plus 1 is n plus 1 into lambda divided by d. So if you subtract both, you will get lambda in lambda divided by d. This is the fringe width that which I wrote written here. So that is why we are able to get theta is equal to lambda divided by small d or beta divided by capital D. So from this, you need to understand one thing, that the angular width of fringe is independent of n, and angular width for all the fringes is going to be same in the case of YDSC. Right. Next is intensity of fringes. So what is going to be the intensity of the bright fringe? The intensity of the bright fringe is going to be 4i, and the intensity of dark fringe will be 0, as I1 is equal to I2 is equal to I. If you take I1 is equal to I2 is equal to I, in the case of YDSC, why in the case of YDSC I1 is equal to I2 is equal to I is because no two light sources can be coherent in nature. Actually, there are two slits, S1 and S2. But how many sources are they actually using? You are using only one source. So from one source, the rays are going, they are getting split as two different sources. From there, you are getting the required answer. Okay. Similarly, I1 by I2 is equal to A square divided by B square. That is equal to W1 divided by W2. Make a note of this point, where W1 and W2 are width of slits, which emanates light intensity of I1 and I2. So please make a note of this point. So all these points, for maximum intensity, I have explained the phase difference, path difference, and all those things. Okay. So the maximum intensity that is possible is 4 times I0, where I0 is the intensity of each source. Okay. So I can also be written as I max into cos square 5 by 2. Why did the cos square 5 by 2 come? Because I is equal to I1 plus I2 plus 2 root of I1 into I2 cos phi r. So that will be I plus 2i cos phi r. So 2i if you take out 1 plus cos phi. So 2i into 1 plus cos phi is 2 cos square 5 by 2. That will be 4i cos square 5 by 2. But 4i is nothing but the maximum intensity. That is why it is written as I max cos square 5 by 2. So minimum intensity means cos 5 by 2 is 0. and 5 by 2 will be equal to n minus 1, n minus half into pi, or 2n minus 1 into pi by 2. Right? This is the one which is not there. You can get questions based on this also. We will be solving it today. So what will happen when a transparent slab is introduced in YDSC? When you have, imagine you have a glass slab in your hand. When a glass slab is kept in between the source and the screen, what do you think is going to happen? When you have a transparent slab of refractive index mu and of thickness T is introduced in one of the path of the interfering waves, then the fringe pattern shifts in the direction. Okay, the shift pattern, the fringe pattern shifts in that direction by distance y, which is given by this formula. Y is equal to capital D divided by small d into mu minus 1 into t. Okay. Interference of thin waves, interference in thin film, we'll see when we do problems. I just want to start few problems, then we'll come back to the theory. So let's start with the third one. Guys, do it. In an Young's double slit experiment, the ratio of the slit widths is 4:1. The ratio of intensity of maxima is to minima. So the ratio of the intensity of maxima to minima close to the central fringe of the screen will be. So how to solve? So what formula can we use that we discussed today?
I1 by I2 equal to W1 by W2.
Okay. So then what should be the answer? Answer should have been in a Young's double slit experiment, the ratio of the slits width is 4:1. The ratio of intensity of maxima to minima close to the central fringe of the screen will be. Sorry, man, you solve use I1 by I2 is equal to W1 by W2. So W1 by W2 is given as 4/1, 4:1. Then I1 by I2, the answer should have been 4:1, right? Right?
So, but then they're asking about the maxima to minima, right? So we have to calculate.
Very good. Very good. If you write it as 4:1, your answer is wrong, because what is I1 by I2?
Yeah,
It is
the
the
intensity.
Intensity of the individual sources, right? So if I need I max, what is the maximum value that is possible? So intensity formula another, guys, I1 plus I2 plus 2 root of I1 I2 cos phi. If I want max, then what should be the value of phi?
0.
0, correct? Up in here,
Square root of I1 plus I2 plus square root of square I1 plus square I2 whole square.
That's right. Square root of I1 plus square root of I2. Correct? Similarly, I minimum will be how much then? Square root of I1 minus square root of I2. This also we know. So, square root of I1 plus square root of I2, the whole square, divided by square root of I1 plus minus square root of I2, the whole square is how much? So, physics part is over. Now we have to think in terms of mathematics.
9 by 1, sir.
That's right. So what did you do? I1 is equal to 4 times I2. Take it and substitute it here, you will get the answer. So root of I1, sorry, 2 root of I2 plus root I2 divided by 2 root of I2 minus root I1, I2 the whole square is equal to 3 divided by 1 the whole square, that is -2. Guys, I hope it is easy and clear. No. Let's try this. The figure shows an Young's double slit experiment. The figure shows a Young's double slit experimental setup. It is observed that when a thin transparent sheet of thickness T and refractive index mu is put in front of one of the slits, the central maxima gets shifted by a distance equal to n fringe widths. If the wavelength of light used is lambda, T will be equal to how much? Formula.
So beta by lambda into mu minus 1 into T.
Beta by lambda. Formula காட்டுறேன் எப்படி யோசிப்பீங்க யூஸ் பார்க்கலாம். Do you remember the formula or not? Here, right? இங்க இருக்கு. எவ்வளோ வரும் பென் யூஸ் பண்ணும். So what did they say? Each shift y is equal to n times beta bar. அப்ப y எவ்வளோ? Beta divided by how much is it? Beta divided by lambda into mu minus 1 into T is equal to n times beta. Beta will get cancelled. N times lambda divided by mu minus 1. This should be the answer, but there is no option. No? Guys, I hope you understood. Yes or no?
Yes, sir.
Okay. Try the next one. In an interference experiment, the ratio of amplitudes of the coherent waves is A1 by A2 is equal to 1:3. The ratio of the maximum intensities of the fringes is. The ratio of maximum and minimum intensities. It is similar to the third problem. Do it fast and tell me what is the answer.
Force.
4. Correct. Others got it?
So doing.
Sorry, da. Want me to explain?
இல்ல சார், I was just doing it. ஏன்னா நிறைய ஸ்கொயர் ரூட்.
Okay. I1 by I2 is equal to root of A1 by root of A2 is equal to 1 by root 3. So I max by I min தான கேட்டிருக்கான். That is root of I1 plus root of I2 divided by root of I1 minus root of I2 the whole square. Correct? root 3 times root of I1 plus root 3 times I1, root of I1. We will get square root plus square root.
ஆமாம் சார்.
Oh, sorry, I made a
Sir,
mistake.
intensity.
Yeah, I made a mistake. A1 by A2, it should be the whole square. 1 by root 3, it should be 1 by 9. Correct, Amma?
Yes.
Is this what you did?
Yes.
Once you get I1 by I2 is equal to 1 by 9, 9 times I1 is equal to I2, take it and substitute it there, you will get the answer. So answer, you will get it as 4:1. It's similar to the third problem. Next. Okay, this concept involves diffraction. Are you guys comfortable with diffraction?
Sir, revise பண்ணிட்டு பண்ணலாமா?
Okay, then we'll go to the next one. Then do the 7th one. So let's practice few interference problems. In Young's double slit experiment, the path difference at a certain point on the screen between the two interfering waves is 1 by 8 of the wavelength. The ratio of the intensity at this point is equal to that of the center of a bright fringe, which is close to. In a Young's double slit experiment, the path difference at a certain point on the screen between the two interfering waves is 1 by 8 of the wavelength. So path difference is equal to 1 by 8 of wavelength. The ratio of intensity at this point to the intensity of the bright fringe is close to. So what is the value of delta x guys? So the ratio of
Sir,
intensity
5 into lambda divided by 2 pi.
புரியல.
இல்லை சார், டெல்டா எக்ஸ் வந்து 5 into lambda by 2 pi.
5 into lambda by 2 pi கொடுத்திருக்கானே நான் 5th ன. They didn't say 5th ன. எப்படி 5 ன்னு தெரியும் உனக்கு? ஓ 5 சொல்றியா? Sorry. 5 into lambda divided by 2 pi. This is what you told. Okay, by finding out 5, what are you going to achieve?
Yes.
By finding out 5, what are you going to, why do you need to find 5? So, the question says the ratio of intensity at the point. So, if I need to calculate the intensity at that point, I need to apply the formula I plus 2i times cos phi. Because here I took I1 and I2 to be the same. See, if in any problem I1 and I2 are not mentioned, by default you can take them as same values. So then around 2i into 1 plus cos phi, that is 4i cos square 5 by 2. Correct? So that is the reason why we need 5. 5 up 5 by 4.
Yes, sir.
4i cos square of 5 by 8. So 4i cos square pi by 8 divided by 4i. The ratio of the intensity at the maximum point to the intensity at the center is 4i. That is nothing but cos square pi by 8. Pi by 8 now 22.5 degrees. What is cos 22.5? Find it out. The square of that value will be the answer. They use the word close to, so you are going to approximate it. Done?
சார் அந்த ஹாஃப் ஆங்கிள் ஃபார்முலா வச்சு போடலாம்ல
Which one? எதை பண்ணோம்?
இல்ல சார் cos square pi by 8 கண்டுபிடிக்கிறது.
Cos என்ன
அது
பண்ணலாம்?
1 plus cos pi by 4 into
அப்படிதான் பண்ணணும். That's what you need to do. You can write as 1 plus cos pi by 4 divided by 2. அதுக்கு என்ன பண்ணலாம்னா இங்கே கண்டுபிடிச்சிடலாம். 2i into 1 plus cos pi by 4 is 1 by root 2. 1 by root 2 is how much? 0.7. So 2i into 1 plus 0.707. 2i into 1.707 divided by 4i. இது 2 times போகும் 0.85 something. Okay. இப்படி கூட பண்ணலாம். I think this is more easy rather than solving it. Do the next one. Consider a YDSC experiment as shown in the figure. What should be the split separation D in terms of wavelength lambda such that the first minima occurs directly in front of the slit S1? It's a good question. Read the question. Do you understand what they are asking? You need to maintain the split separation in such a way that the first minima is exactly supposed to be formed opposite to the slit S1. So how is it possible?
sir y should be 0.
Why another? That's the first maxima. Minima le measure. They use the word minima, they don't use the maximum. See, generally what will happen, the central spot will be this one. They have given the distance between the slit and the screen as 2D and the distance between the slits is D. What should be the split separation T in terms of wavelength lambda such that the first minima directly occurs? So what are the condition for minimum? Let's go with the basics. Let's go from the basics. What are the condition for minimum? Delta x is equal to odd multiples of lambda by 2. So minima number they are speaking is n is equal to 1. So what should be the value of delta x? It should be lambda by 2. Let this be equation number 1. Okay. So what is the formula for path difference? It is S2P. I am able to see that S2P is longer than S1P. So S2P minus S1P is lambda by 2. Correct? Will we be able to apply some mathematics and find out some trigonometry or whatever it is?
ஆமா சார் என்ன sir so tan the tan S1P S2 will be equal to 1 by 2.
Tan எங்க angle எடுக்கற? Where are you taking the angle?
That S1P S2.
You want to take this as theta. Okay.
Yes. The user sir.
Let's think, no? Okay.
D by 2D னு வரும் அந்த
D divided by 2D. So you want to say tan theta is half. Okay. S2P minus S1P, what can we do?
சார் அந்த பைத்தாகரஸ் தியரம் யூஸ் பண்ணிட்டு
பண்ணலாம்.
அந்த ரூட் அது வந்து ரூட் 5D minus 2D so equal to lambda by 2.
வந்துருச்சு ஆன்சர். Is there an option?
Yeah, yes, sir. See,
That's it. Lambda divided by 2 into root 5 minus. That's the answer.
sir, but Anna, how did we know that exactly the first dark fringe will be ahead of S1?
No. The system is designed in such a way. Okay, அவன் என்ன சொல்றான்னா இந்த d ஓட value we don't know.
ஓ, ஃபர்ஸ்ட் மினிமம் கொடுத்துட்டாங்களா? ஓகே.
Yes, they have told. அது அப்படி adjust what should be the distance so that அந்த இடத்துல first minimum form ஆகும் கேட்கலாம். So you have to design the system. அதுதான் main. Okay. Proceeding. We'll do one more problem based on YDSC, then we'll go to the fraction. In a Young's double slit experiment with a slit separation of 0.1 mm, in a Young's double slit experiment with slit separation as 0.1 mm, one observes a bright fringe at an angle theta is equal to 1 by 40 radian by using wavelength lambda 1. When the light of wavelength lambda 2 is used, a bright fringe in the screen at the same angle in the same setup, given that when the light of wavelength lambda 2 is, did I miss any part of the question? When the light of wavelength lambda 2 is used, okay. So let me read the question again. In an Young's double slit experiment, the separation 0.1 mm, one observes a bright fringe at an angle of 1 by 40 radian by using a wavelength. Okay. Question புரியுதாடா? Suppose
என்ன சார் ரெண்டாவது கேஸ்ல என்னோட வேல்யூ மாறுமா?
Yes, அதான் என்னோட வேல்யூ will be different. That we don't know whether lambda 1 is greater than lambda 2 என்னன்றது நமக்கு தெரியாது. Okay. So first case la, let's say the third bright fringe is formed at a particular point, maybe using wavelength lambda 2 you are getting a fifth bright fringe, you don't know, but the angle is same in both the cases. Now what are they asked? Given that lambda 1 and lambda 2, we know only one fact, that lambda 1 and lambda 2 lie between 380 nanometer to 740 nanometer. We need to find their values. How do we proceed? So what is the condition? What is the angle subtended at the center by an nth bright fringe? Is it not n into lambda divided by small d?
Yes, sir.
Okay, small d. By using this, what are we going to do? So theta n, and let's say there it is theta n plus 1 or something. Or let's take it as n1 and n2. n1 lambda 1 divided by d. And theta n2 will be equal to n2 lambda 2 divided by d. இப்போ இதோட ரேஷியோ ஏதாவது கண்டுபிடிக்க முடியுமா? theta n1 is equal to theta n2. So n1 lambda 1 divided by d is equal to n2 lambda 2 divided by d. Cancel them. So n1 lambda 1 is equal to n2 lambda 2. n1 எவ்வளோ? That we don't know. So any other data you can find out?
I think the answer could be D இல்லாட்டி B இருக்கலாம் சார். ஏன்னா அது டிவைட் பண்ணா n2 n1 must be a whole number. அந்த மாதிரி can you just
Yeah, that's
so
what
it
I'm thinking.
probably will be B இல்ல சார்.
Probably B 400 and 500 சொல்றியா?
ஆமா சார். ஏன்னா then only n2 and n1 will be like a integer அந்த மாதிரி.
இல்ல அந்த மாதிரி கூட யோசிக்கலாம். But I think some data இவ்வளவு தான் இருக்கா? I think we have to go with trial and error. You know, data is insufficient in the question. So many unknowns, 4 unknowns, we have only one equation. So we have to go only with trial and error method. So what can we do? N1 lambda 1 by lambda 2 should be an integer, correct? 3
Sir,
not,
B, D ரெண்டுமே satisfy பண்றது சார்.
Not necessary. See, N2 and N1 should be separately integers. So for example, 500 N2 500 இருக்குனா N1 4 இருக்குனா 5 by 4 need not be an integer. So அதை வச்சு கண்டுபிடிக்க முடியும்.
ஓ ஓகே.
அப்படி இருக்கணும்னு அவசியம் இல்லை, but just seeing if there is something missing in the question. Lambda 1 by lambda 2 is equal to, they didn't speak anything about the greatness, or we don't know which wavelength is more and which is less. Options kuda pathana, there are conditions where first is low and second is more and vice versa. Actually question konja ambiguous ah irukku, but let me think in a different way. We'll do one thing now. Let's see if you're able to find lambda 1 from the data, because we cancelled that 1 by 40. Let's see if the data is useful for us. 1 by 40 is equal to n1 into lambda 1 divided by d over 0.1 millimeter. 0.1 into 10 power minus 3. So n1 into lambda 1 evolo varuna 10 power minus 4 divided by 14 எழுதலாமா?
சார் பட் ஆனா செகண்ட் கேஸ்க்கு எப்படி சார் மாறுறது?
அதான் நான் ட்ரை பண்றேன்டா. I want to find out what is the value of lambda 1. Can you find out what is the value of lambda 1 in terms of n1? So we'll do one thing. 1 by 4 into 10 power minus 5. This is n1 lambda 1. So n1 lambda 1. 0.25 into 10 power minus 5. So can I write this as 25 into 10 power minus 7 meter? So lambda 1 is equal to 25 into 10 power minus 7 divided by n1 in terms of meter. Can I write this in, see, generally when you represent lambda, right, the lambda should be either in terms of nanometer or angstrom. I'm trying to write it in terms of nanometer. So 2500 into 10 power minus 9 meter divided by n1. So 10 power minus 9 meter na 2500 nanometer by n1. Okay. அதே மாதிரி lambda 2 என்ன வரும்? Only difference is going to be 2500 divided by n2 nanometer. Okay. Now what are all the values of n1 and n2 that we can keep substituting? So if I substitute n1 is equal to 1, then I'll get 2500. 2500 option illa, because it is a visible range. N2 is equal to 2 substitute panna. Sorry, n1 is equal to 2 substitute panna. I'll get 1250, which is also not in the range. N2 is equal to 3 panna, 800 and something. 800 is also obviously not in the range. So N2 is equal to N1 evlo substitute pannu. You substitute it as 4, then what is the value of lambda 1? 625 nanometer. So lambda 1 will be 625 nanometer. Adhe mari N2 can also N2 la vandu you have to substitute a value greater than 4. So N2 is equal to 5 substitute panna, we'll get 500 nanometer. So the option can either be 625, 500 or 500, 625. So in the option match up. Guys, did you understand what I did? This is actually a complicated problem and a good one. Suggest you guys to practice it again. Did you understand what I did?
Yes, sir.
Right. Now we will proceed to the diffraction points. See, diffraction, I hope you guys remember how this phenomenon takes place, right? So diffraction means what? It is a phenomenon where the light starts bending when it hits an obstacle. When will the diffraction pattern appear like an interference pattern? When the size of the opening is comparable to the, not comparable, it's very small compared to the wavelength of the light that is being used. Okay. What is the condition for central maximum?
Path difference 0.
Path difference is 0. That's right. So what is the condition for first secondary maximum? So what are the condition for the first secondary maximum? We will get something like this: a by 2 times sine theta is equal to lambda divided by 2. So a sine theta will be equal to lambda, then theta will be equal to lambda divided by a. Do you guys remember this? Let me explain this. So central maxima, a ray from here, a ray from here, will travel equal distances, hence path differences 0. No confusion in that. After this, you have to explain what is the reason why there is a minima taking place at this spot. So what is the explanation we are going to give? That this A is divided into 2 equal parts. Such that if you take a ray here and if you take a ray from here, these 2 rays will travel in such a way that these 2 rays will go and hit the screen with a phase difference of how much value? With a phase difference of lambda by 2. So a by 2 times sine theta is equal to lambda by 2. Cancel it. So A sin theta will be equal to lambda. So sin theta will be equal to lambda divided by A. Right. So what is this is the condition for minimum. So how does the secondary maxima form on the screen? So how does the secondary maxima form this? You will break the slit into how many equal parts?
3.
You will break it into 3 equal parts in such a way that in between those 3 equal parts, you can find 3 different rays that are coming out. Then how are these rays supposed to interfere at that point such that you have a secondary maximum?
So 2 will destructively interfere and then 1 will constructively interfere.
One will constructively. Those 2 also, it is not the first and the third one. It should either be first and second or second and third. They should be the consecutive ones which will go and hit the screen destructively. So if that is the case, then what is the condition? A by 3 times sin theta will be equal to how much? Lambda divided by 2. So A by 3 times theta is equal to lambda by 2. So A will be equal to, theta will be equal to 3 lambda divided by 2A. This is the condition for first secondary maximum. இதே மாதிரி நீங்களே சொல்லுங்க, what will be the condition for second minimum? Sin theta will be equal to 2 lambda divided by 8. What will be the condition for third minimum? Sin theta will be equal to 3 lambda divided by 8. போயிட்டு இருக்குமா? So what is the condition for the nth minimum? N times lambda divided by 8. Or I can write A into theta n is equal to n lambda. Now what should be the condition for second secondary maximum?
A by 5 theta equal to lambda by 2.
Lambda by 2. So theta will be equal to 5 lambda divided by 2. So what will be the condition for nth secondary maximum?
2n plus 1 lambda by 2a.
That's it. So this is the condition, and that's what they've given here. Okay. And one more important point that we already know is angular width of the central maxima is always double the angle of double the width of any other maxima in the case of diffraction. So this is a concept that you're supposed to know. Based on this, we will try out few problems. One such problem is this thing. I want you guys to try.
Sir, can you repeat that point?
Which point should I repeat?
And
Width
the
of central
last
maxima.
one. Yes. Sir.
Yeah. The width of central maxima in the case of diffraction is always double the width of any other secondary maximum.
Yes, sir.
Okay. Now there is a question like this. You have a double slit experiment in which there is a green light which falls on a double slit having a separation of 19.44 micrometer and a width of 4.05 micrometer. The number of bright fringes between the first and the second diffraction minimum is. So try to draw the diagram and understand what they are asking. So what have they given? Wavelength is given, which is 5303 angstrom. Falls on a double slit having a separation of 19.44 micrometer and a width of 4.05 micrometer. The number of bright fringes between the first and the second diffraction minima is how much? So what will happen here is, so did you guys understand the question first of all? Did you understand what they're asking? They're using the word double slit, but they're asking about the first and second diffraction. Did you understand what they're saying? See, you have a screen. How many slits do you have? You have two slits, S1 and S2. In general, what happens is when we speak about Young's double slit experiment. So what is the main reason why Young's double slit experiment is able to produce a pattern on the screen? What is the principle on which it is based upon? Interference, right? So when the interference is taking place, you're able to see the consecutive bright and the dark fringes on the screen. Okay, that is accepted. Now, when you take each slit, we never speak about the width of a slit in the case of double slit experiment. Now, can I say, if I forget about S2, if I treat S1 alone as a single source, then the light passing through S1 will undergo diffraction. Similarly, the light passing through S2 will also undergo diffraction. Purida. So this is the maxima, whether it is going to be a diffraction pattern or interference pattern. So try to understand one thing, guys. When you talk about YDSC, along with the interference, there is also diffraction that is going to take place. So that's what this problem is all about. That is why it's tricky. That's why it's a bit confusing. Now this is the maxima. Now try to observe the number of bright fringes between the first and the second diffraction minimum. So you have maxima. Let's say this is the distance they are trying to ask. Okay. So they are trying to ask you certain distance. How will you be able to relate to this distance in terms of a given data? In terms of given data, lambda is given, d is given, lambda is given, a is given. Correct? So what is the formula or mathematical expression that we can think of that relates lambda d and lambda a? It is nothing but the angular width, because I can find the angular width in the case of diffraction. Angular width in the case of diffraction between first minima and second minima is how much? Anybody? What is the angular width between two successive minima? It is lambda divided by a. The same angular width in the case of YDSC is how much? It is lambda divided by d. The difference is here also lambda by distance, here also lambda by distance. In the case of diffraction, A represents the width of each slit, Whereas in the case of IDSC, you are not concerned about the width, rather we are concerned about the distance between each. Okay. Now what we can do is lambda divided by A and lambda divided by D. In both the cases, the same green light is used. Okay, in both the cases, the same green light is being used. But remember one thing, though diffraction will take place in every other case, the diffraction should take place in such a way that it should support the interference that is taking place. So for that to happen, look, here A is in the denominator, here D is in the denominator. Okay, so which one will be less and which one will be more?
D should be more.
Lambda by A will be more because the denominator is less, and lambda by D is less because the denominator is more. So what we can do is, we can say, now look at the way I'm going to relate the angular width in the case of diffraction and interference. Lambda by A, I will write it as n times lambda divided by D. So that this lambda will be equal to this and this will get cancelled. D divided by A, that is 19.4.05. If you divide both, the answer should be somewhat close to 5. Okay. So this is a very, very good problem. If possible, you try to solve similar kind of problems by finding from the book which I gave you. Okay. Next.
So
Tell me.
first diffraction minima and second diffraction minima means like we're asking about the first secondary, like the distance between the first secondary minima and the second.
There is nothing like first secondary minimum. That's only first minimum in the case of diffraction. First
yes.
secondary maxima. Okay. They're asking the distance between the first minima and the second minima. So if a double slit use pannumbod, when you use double slit, no, though there is going to be diffraction that is taking place, the diffraction should be in favor of the YDSC. That is what I'm trying to say. So enna solla varana, diffraction if at a particular place on the screen, if there is a dark spot, due to interference also there will be a same dark spot. Okay. So in the case due to diffraction, here there is a dark spot and here there is a dark spot. Let's say this is the first and this is the second dark spot. If I take this as theta, the formula in the case of diffraction tells me that theta is equal to lambda divided by A, which is the angular width of the distance, which is the angular width between the first and the second minimum. If a second and third is it is lambda by A only. But what will happen due to YDSC is, see, explain inge dark spot, inge dark spot. But it doesn't mean in between there will be only bright spot. There can be multiple bright and dark spots that are taking place. Those bright and dark spots are taking place due to Young's double slit experiment. This first and second dark spot have taken place due to diffraction pattern. So in the same width, there will be n more spots that are formed due to whom? Due to the double slit experiment. That is why I wrote it as n times lambda divided by D.
Okay, sir.
Okay. So let's try out few problems based on YDS diffraction. Here everything is combined. Did any one of you get diffraction based problem in the JEE question paper? Not many problems are there. So I'll suggest you guys one thing. You go through the problems from the book which I gave you based on diffraction. If there is any doubt, reach out to me. In the next class, I will start polarization. That is very important. Okay, because you have not learned it completely, I will teach you in depth. So if there is any other doubt also, what you do, you go to the CPSC part and go through the diffraction which I have explained. If you still have doubt and derivation, go there and verify it. If there is any doubt, let me know tomorrow. I'll first clear your doubts, then I'll go into the polarization concept. Okay. So tomorrow, do you guys have school?
No, sir.
All right. Very good. You don't have, right? So tomorrow, if possible, if I'm not going in the morning to board, I will take class in the morning, or else I'll take it at the same time. Okay. So that depends. I confirm it by tonight, or maximum by tomorrow morning. So please be alert to the WhatsApp morning part.
Okay.
So I'll see you guys tomorrow.
Thank you.
Thank you, sir.